there isn't actually a lot of experts out there when it comes to SARS-CoV-2 because it's a novel virus. A lot of us are just learning about it, and everything that we know is changing week by week with this virus. So firstly, I'm not offering expertise in this particular coronavirus, but just interpreting a lot of stuff that's out there from a scientific point of view. I've been working in the field for around 6 years in total. And as you already alluded to, we've been discussing some issues over social media, Facebook, WhatsApp, and you talked about how it would be good for more people to have access to the kind of information that I have. I'm essentially an infectious disease scientist in training. I did a master's degree in molecular biology, and I've worked in a lab setting on various pathogens, including vaccine preventable or infectious diseases. And I'm now in my 4th year of being a PhD student. There's a lot of the problem that I'm seeing with the misinformation is that sometimes people don't interpret the literature properly. Actually, new research has shown that coronavirus, specifically SARS-CoV-2, is actually evolving quite slowly. It's changing at about a rate of 2 mutations a month. So that's actually very good news. It means that there's a real chance that we might be able to get a vaccine for this that can induce long-term immunity. So that's quite good news. And these viruses, what they usually do is they will either mutate inside of an animal reservoir and then they spill over to humans, but the infection source is still animals. Whereas what this coronavirus has done is it's spilled over into humans and we have human-to-human transmission. A lot of viruses undergo recombination event, kind of part and parcel of how they change over time. They're rapidly evolving, rapidly mutating. And so, for example, the flu virus mutates every year. That's why we need a new flu vaccine every year. And then if we compare it to the flu goes around every year, and some people say, oh, it's just the flu. I don't think there is just the flu. I think people mix up cold viruses and flu viruses, and there's a lot of muddy water there. But if we compare it to genuine influenza, and you look at the reproductive number, which is how many people, if you're infected, will you then go on to infect? And for flu, it's 1.3. So that means 1 1/3 people is about what you would go and infect if you're infected yourself. And if we look at SARS-CoV-2, this is, I mean, people don't really know at this stage an exact number, but they're estimating between 2, 2.5, and maybe even 3. So we can actually change that reproduction number. That depends on the immunity in the general population. So if you're only having contact with the 3 people in your house, yes, you could go on to infect them, but they're not infecting anybody else. So it changes the reproduction number quite a bit. I mean, just for example, I've got a figure here that in the first 7 days of lockdown in Wuhan, the reproduction number dropped to 1.05. So that's just by locking down. So that's why it's so important. And in terms of incubation time, for influenza, it's 1 to 4 days, but for SARS-CoV-2, it's 2 to 14 days. So that's a long incubation time. For some studies, they've actually shown that even when you're asymptomatic, be it pre-symptomatic or post-symptomatic, so before you're showing symptoms, there is a chance that you could be infecting others. So the way that they've actually showed this is a study where they've looked into the viral load in the nose and the throat when people are not symptomatic and when people are symptomatic. And they found that although it was a low viral load, they still found detectable virus in the nose. That means if you're rubbing your nose or, say, for example, removing some bit of irritation on your nose and then you go and touch a surface, there is a small chance that you could still transmit it. When you're asymptomatic, a lot of the spread is actually through symptoms. So when you're coughing, you're expelling virus. When you're sneezing or blowing your nose or touching your nose, then obviously there's a lot more coming out. So you're actually generating respiratory droplets. And so a lot of how it's spread is through symptoms. But it doesn't mean when you're asymptomatic, when you don't have symptoms, that you can't transmit at all. So we all need to still be very careful, even if we're not showing symptoms. The amount of virus that you're getting in the beginning does have an effect. And so also when we're talking about, we were saying, okay, so on steel, for example, it can be on steel for up to 48 hours. It can be on cardboard or paper for 24 hours. It doesn't stay on the skin for that long if you're washing your hands. It doesn't stay on those surfaces for that long if you're wiping them down with a bleach solution and killing all the virus that's on them. So I've been getting a couple of messages from people saying that now it is airborne. And then they're sharing a link to a reputable journal. So it looks very legitimate. But when you click on the link and you go and actually read the article, it talks about aerosolized virus in a clinical setting staying in the air for 3 and maybe up to 8 hours. But that doesn't mean it's airborne. Aerosolizing virus happens in a clinical setting. So for example, when a doctor is intubating a patient or putting them on a ventilator, something like that, then there can be aerosolized virus. So that doesn't mean it's airborne, and when you go outside, it could be floating around in the air. That's not the case at all. When I sneeze, they kind of go out into the air, and they say for about a meter. So if I sneeze and I'm expelling a respiratory drop for a meter, and you're standing about a meter to a meter and a half away from me, and you then breathe in those droplets, that's how you can get infected. Or they land on your hand or on a surface and you touch that, and then you touch your eyes, nose, or mouth. That's how you're going to get infected. It's not like me breathing in the same room 2 to 3 meters away from someone, I'm just going to get infected. It would have to enter, it doesn't enter your body through the hands, and it's not going to enter your body from breathing near to a surface that someone has touched 24 hours ago. So if you go into any setting, you go to the shops and you lean against the counter and they say it's also staying on plastic for up to 48 hours. That's under the presumption that no one's cleaned that surface. That's under the presumption that somebody who has been infected has actually coughed onto that surface. So there's a lot of presumptions that are in that data, if that makes sense to you. There's 2 ways when you're washing your hand that you get the virus off your hands. A, the soap can actually disrupt the envelope of the virus, and B, it makes the surface slippery, and so it actually rinses the virus off. So it depends on how kind of sticky the packaging is and how well the virus actually adheres to it. But what we've been doing in our house is we've got a 1% sodium hypochlorite solution or a bleach solution. So household bleach that you buy in the shop is generally 5%. So we've made it down to 1%. And as we're bringing things in from the shop, we're wiping it down. And then it's unlikely that there's any virus on them. Also taking off any clothes that we went to the shop in and washing them immediately, washing hands. So what I did, I had to go to the shop today. I had to go and get some medication. And before I walked into the shop, I washed my hands so that if there's any chance that I've been infected and touched my nose or rubbed my eye or something like that, and then I've sanitized my hands, so I'm now not spreading it. Even in the house, every time, for example, you get a bit of a dry throat and you cough, and you're so used to doing this with your hand and covering your cough, and now your hand's infected. So going and immediately washing my hands after that so that I'm not touching things and putting them onto a surface. So that's what people can be doing to stop the spread. And then anything that you're touching, any surface that you're touching, it's actually not helpful to use gloves if you're going to the shop. It's a false sense of security. In a clinical setting, when a doctor is using gloves with a patient or with a surface, they're changing gloves between each person. We're not doing that when we go to the shop. Every time we touch a surface, we're not changing gloves. So then we're, for example, touching a surface, scratching our shoulder and putting a bit onto our clothes. Then you take the gloves off when you get back from the shop, you're touching your shoulder, and then you touch your mouth. Or any other part of your body. Put your phone away when you go to the shop. Otherwise, you're going to touch a surface, touch your phone, it's on your phone, and then you wash your hands, touch your phone, and you're picking it up again. So herd immunity is a very important strategy that we discuss when we're talking about vaccines. And it's important to know the difference between herd immunity that is induced with a vaccine versus herd immunity that is induced with actual disease, especially when we have a pandemic circulating that none of us are immune to. So the first thing we need to consider is when you give a vaccine, the person doesn't transmit the vaccine strain, generally what you've given them. So say, for example, if I'm immunized against chickenpox, I'm not actually able to give you chickenpox. Whereas if I get chickenpox as a disease, I'm able to spread it to you. So with disease versus a vaccine, you can actually transmit the infection if you're infected yourself. And the second thing is there's a lot of very real risk. So yes, 80% of us roughly are going to be okay if we get this. We're going to show mild symptoms. We're not going to need a medical intervention. But there's those of us who will get a lot sicker. And that category is those of us who have comorbidities. So a comorbidity could be kidney disease or a heart problem or a lung problem like asthma. And a lot of us have underlying conditions that we don't yet know about. So that's the problem. It can spread through a healthy young population and can actually cause someone who's in a healthy category to get very sick because they have an underlying comorbidity. So that's the risk with this. So generally vaccine programs will target younger children because most of them are not immune, and the diseases that can circulate are a risk to children. So what they've said with this herd immunity strategy is that young people, especially children, don't seem to be a big risk for getting sick, but they are still a risk for transmission. So they're going homes and they can then transmit to their parents, they can transmit to their grandparents, they can transmit to anyone around them who has one of those comorbidities like a cardiovascular disease or chronic obstructive pulmonary disease or asthma or anything. I mean, our first death here in South Africa is a 48-year-old woman. That's not in the age category for risk. However, she apparently had a pulmonary embolism. When they talk about risk groups, they're talking about risk groups for severe disease. They're not talking about, it doesn't make me more susceptible to getting the infection in the first place. It just affects the course of disease. So what is herd immunity? Herd immunity says that generally everyone around you is immune. So if you get infected, you actually can't infect them because they're already immune. And so if I'm not infecting you and you're not infecting the people around you, it kind of stops the spread. This virus has a spike protein on it, which is a receptor binding domain and a cleavage site. So this is how it enters our cells. So they actually match to a receptor on our cells called an ACE2 receptor. And this is involved in angiotensin and various other things, which I don't think it's important for us to discuss. But I think what is important is to know that people who are diabetic or people who have cardiovascular disease have more of these receptors on their cell surface. And these receptors are found on cells in our respiratory system, some in our gut and some in our veins, but mainly in our respiratory system. So if you think about a house that has 5 doors versus a house that has 1 door, and you've got a whole bunch of invaders outside that you need to defend your house from, you can just block 1 door and then they can't get in, or they're only entering through 1 door, so you only have to deal with 1 of them at a time. Whereas if you have 5 doors, there's 5 entry points. So that's the difference with this virus and why it's so dangerous to those risk groups. Asthmatics have generally, obviously, lungs are differently able to cope with respiratory pathogens, and that's known for all respiratory pathogens. So that's a general rule. So that's why I say the clinical course. So it's not that, for example, a person who has cardiovascular disease is more likely to come across the pathogen and get infected. It's how it acts in their body, because many more viruses can get into each cell at each time. And so the rate at which it moves through the body is so much faster. And will our immune systems be able to catch up? Those are the sort of things that you're considering when you look at the risk. And inside our bodies, what the virus actually does is it will enter a cell, and it's an RNA virus. And the RNA actually has, I guess, the instructions for our cells to then make many copies of that virus. They then go out of the cell and go to infect new cells. And that's kind of how it passes through the body. And so our immune system would recognize it, and then it would produce things called cytokines, which are chemotaxis proteins. And what chemotaxis is basically chemicals or proteins in our body that say to other cells, hey, come here, and they guide them where to go. So it's calling a lot of other immune cells. So the other immune cells get there, and then some of them will fight the virus, but some of them attack our own cells and say, hey, you're infected, kill yourself. But then some of our immune cells also get infected, and then that's where confusion starts to happen. And so those cells can also attack our own cells. They can then also produce more virus, and they also get confused and start calling more cells than immune cells than are necessary to come to the site. And that's where a lot of problems can come in, because then you're generating fluid on your own respiratory system in your lungs, and it becomes difficult to breathe. And they actually destroy the lining of the lungs, and then oxygen exchange becomes difficult. So the rate at which this happens and the rate at which we start to recover is important, because once our own immune system can start to actually fight the virus and overwhelm the virus, and then there's no more virus in our body, and then we start to become asymptomatic again. Or post-symptomatic, I think we should rather call it. And then there's not a lot of evidence out there to say whether there's long-term immunity, but generally with a virus, you would then be immune to the virus. And so the next time you come across it, your body knows what it is and knows how to deal with it, and has the specific cells to actually fight that. So it's almost like a training program, if you want to think of it that way. So the first time you get attacked, your body doesn't quite know how to fight this new threat, and it eventually figures it out. And once it's figured it out, it goes back to the other cells and says, okay, we know how to defeat this. This is the way. Let's train a couple of you to move around the body. And the minute we know that that virus is in the body again, we're going to mobilize more of you who know how to deal with it. So that's kind of what long-term immunity is. This is not going to happen to everyone. A lot of people who are healthy, I guess, are going to have mild symptoms. So maybe a sore throat, a dry cough, some body aches, etc. So that's kind of, we've got to look at the course of the disease here in the body. Is it going to get defeated when it's still in the nasopharynx area? Or is it going to have the opportunity to move down into the lungs? Is it going to be defeated by our immune system quite soon? Or is it then going to go down and cause severe respiratory or acute respiratory distress? And that's the question. It's not going to happen like that in everyone. Precautions. Pretend that you might be infected, or anyone around you that's touched those surfaces could be infected, and act accordingly. So wash your hands after every surface contact, or sanitize them. If you can't do that, make sure you don't touch your face, and then as soon as you can, wash your hands. I think that's one of the most important ways that we can stop the spread. And also just by not going out, by staying home. Every time you're going out into the outside world where other people that could be around you are infected, you're increasing your chances of catching it.
Right.
It's so multifaceted, and it's a difficult question to answer. But I'm going to just mention a couple of things. So firstly, a lot of places are reporting that they don't have any infections. Is it because they don't have any infections, or is it because they're not looking for those infections? So obviously, Wuhan was the first city that was affected, and quite soon into, I guess, the viral outbreak, they were able to actually publish the sequence of the virus. And being able to do that meant that molecular researchers could actually look at regions of the disease, the gene of this particular virus that were unique, and actually target those with molecular testing. So in molecular testing, they're saying, is this part of the gene there? So do we have it or don't we have it? Is it there or not? And so this process obviously took a little while, and for these molecular testing methods to get out. And molecular testing is also quite expensive, and it's not affordable to every single lab, and you have to have a certain amount of expertise. So for example, in the USA, there was a problem, and I can't remember the specifics of it, but there was a problem in getting the testing kits out. So they were actually slow to start testing and actually quantifying how much disease there is out there. And we're also only getting the numbers from people that were testing. So I think a lot of countries weren't looking for it. I mean, I've seen a study that was published on Nature's website saying that Italy had circulating virus and symptomatic patients before they actually started looking for it. So they're saying weeks before they actually had it already circulating. So by the time they said they had 200 cases of positive for SARS-CoV-2 patients, it was already circulating around other people who perhaps had mild symptoms, but were still spreading it and transmitting it. So that's the problem. When you have a certain amount of the population who are susceptible to severe disease and requiring hospitalization, and they're all being admitted to the hospital or trying to be admitted all at once, that's where the problems come in. So I don't know if that answers all your questions. You can follow up if you need. We're still in the early stages, and I think it is going to get, if people don't lock down and take the lockdown seriously and stop the spread from being so rapid, I think a lot of our health systems are going to be overwhelmed. And the clinical prognosis for people also depends on what treatment they're given. So with this virus, it's not like there's any treatment out there or any vaccine. So it's not like you get admitted to hospital and they can give you a particular antiviral tablet which can solve everything. They've got to treat it symptomatically. So if you're not able to breathe and get oxygen into your system, they need to put you on a ventilator. If that ventilator is not available, then you're not able to breathe and get oxygen into your system, and then you die. So I hope that makes sense to you. So when you've got a lot of severe cases presenting all at the same time and you're not able to manage the clinical symptoms, then you're going to get a lot more people dying. And that's the reality of this. And why it's so dangerous is because we're infectious for a long time. I mean, there's been studies out there that have shown that even up to 13 days after someone has stopped showing symptoms, they can still be transmitting the virus. That's quite scary. And that is completely not immune to this. So it is going to spread rapidly. But just to give you an example, so there was a simulation study that was done by one research group, and I can't remember which journal it was published in. I'll have to find it for you. But it basically showed that if in Wuhan they had instituted lockdown 3 weeks earlier than they did, they would have prevented 67% of the cases that they had. And if they'd locked down 3 weeks before that, they would have seen only 5% of the cases that they're currently seeing. And so that kind of gives you a bit of a picture. Yes, probably experts are saying that 20 to 60% of us are going to get it. But it's if we're all getting it at the same time and transmitting it at the same time, and all those severe cases that are in the risk groups that go on to cause severe disease, that then need a lot of hospital resources, if that's all coming in at the same time, then more people are going to die. That's the important message here. we have to look at, I guess, testing the same way that we look at something that's in the store that's been bought up, like all the hand sanitizer. It's a limited resource. So if you're buying all the hand sanitizer and keeping it in your house even more than you need, then that's a resource that other people don't have available to them. And it's the same with testing. There's a limited amount of staff in any country that are qualified to actually do that testing. The enzymes and whatnot that are required for molecular testing. Those things are, it's a limited resource. So if we're testing the whole population, we're going to actually run out. So that's why they've approached this from a contact tracing and testing point of view. So they're not just testing anyone. They're testing the people that they need to test to say, hey, isolate yourself. And in this pandemic, the way that most countries have been approaching it is they've entered a phase where they say, okay, anyone that we know that tests positive, quarantine them, isolate them so that they can't spread it to others. Find out who they've been in contact with, test them and isolate them as well. But then you go past that and you go to a stage where it actually doesn't really help to test everyone anymore because so many people have it that the resource is going to run out. And so we say, okay, lockdown. Limit your contact with other people and limit the chances that you're spreading it and giving it to other people. We're still going to go through and contact trace, but we can't test everyone. And it, like I've mentioned before, it doesn't actually change how your prognosis, whether you have COVID-19 disease, which is caused by SARS-CoV-2, or whether you have another viral infection. There's no treatment that's specific to this. They're treating the symptoms. So the people who are on the other end of the line, the people who are testing you, they're also trying to do the best that they can with the resources that they have. They're trying to stop the spread, advise who should isolate, but also maximize the resource. That's the difference in diagnostic testing, I guess. So at the moment, we're mainly testing with molecular testing. So that's looking for the virus genes in your system. So we'll take a nasal swab and we're actually testing for the presence of the virus. If the virus is not there, it's not going to be detected. And so then it will kind of, you know, if you've had it and you no longer have it, then we're not going to detect it. We're not going to be able to say you've had it. But then if you do immune testing, which is where you actually look for antibodies to the virus, so our own immune response to the virus, which you've got to remember will take up to 2 weeks. So, you know, testing for that while you've got the symptoms may not be helpful. So it's diagnostic testing and where it's applicable. So if you think someone currently has it, molecular testing is the best way to go. If you think someone has had it and you want to check if they've had it, immune testing is the way to go. So then you're actually looking for immunity antibodies specific to the virus. And yes, there have been a couple of tests like that that have been developed. But again, that's a resource that takes machinery and reagents. That's the word I was looking for earlier. Reagents that are expensive, reagents and machines that need a qualified person to actually run them. So all of that is going to be done in time. I mean, epidemiologists are going to want to know who's had this, how much of the population is immune, etc. But we're not at the stage where we can actually do that right now. You going into a facility to get a test, if you haven't had it, is a big risk. It means that you're exposing yourself to possible infection. And if you do currently have it and you're pre-symptomatic or post-symptomatic, you know, you could be exposing others to yourself. So that's why it's not really too much at this stage. Generally, if we use vaccines as an example, if I vaccinate you today, it's going to take up to 2 weeks for you to mount a full immune response that is protective against the virus. So that's what we need to do, is say, okay, those people out there who have had it, they need to be not spreading it anymore, and they need to have mounted a big enough immune response so that they're not going to spread it. So just what we're trying to do with the lockdowns is try and slow everything down. Slow it down until we find, for example, a treatment that we can use that is more effective. We don't know what's effective at the moment. There's a lot of theories out there, but they need to actually be tested before we can use them. Slow it down to a rate that is more manageable for the healthcare system so that they can prevent as many deaths as possible. Slow it down until we found a vaccine candidate and had a chance to actually test it and know that we can give it to the population. Those are the kinds of things that we're aiming to do here. And, you know, if we've got only one or two, even if we have a second wave and a third wave, if we can catch those cases early and contact trace and make sure we're quarantining those people, we're still slowing down the spread. So because this is a worldwide pandemic and we're in the middle of it and it's dynamic and it's changing week on week what we know about it, obviously slowing it down gives us the benefit of knowledge. I mean, just for example, if it had hit every country at the same time as it hit Wuhan, we would be in a much worse state. We've learned a lot of lessons from Wuhan about how it's transmitted, how to test for it, what effect a lockdown can have, all of those things. So we need to slow it down as we're learning so that we can catch up, so that our immune systems can catch up. It's a very difficult question, Steve, because there's a lot of complexity to our immune systems. And yes, you can better equip your immune system to deal with an invader. And ways that we can do it is to leave open resources for our immune system. So say, for example, you're drinking. Alcohol is a toxin. So drinking a lot of alcohol means you're putting a toxin into your body that your immune system is having to deal with. There's a lot of resources in your body, not just the immune system, a lot of energy resources that are now going to be directed towards dealing with that now aren't available for dealing with a virus that's invading your system. And the same to do with getting a lot of sleep. Make sure there's a lot of energy resources available to your immune system that it can rapidly, just as rapidly as the virus, I guess, start to actually reproduce itself, send more immune cells to the site to actually deal with the virus. And like you say, having a healthy diet, all of that really does help. And I think a lot of governments are pushing that at the moment. I'm not really qualified to speak on dietitian matters. Maybe you could have a conversation with a dietitian the same way that we're having a conversation, and maybe they've got a lot of information on that. And the best way to do that is to eat healthily and make sure you're getting all the vitamins, minerals, and micronutrients that your body actually needs. Everyone who is getting information should be looking at it critically and seeing what source does it come from. Hey, yeah. Sarah said this, let me just look that up and actually be critical of the source and ask yourself, is this source actually helpful? Because there's a lot of stuff being shared out there, like conspiracy theories. And you and I were discussing, looking at it and saying, is it helpful? Does it matter whether it was man-made or came from an animal or what animal it came from? We're in the middle of a pandemic, and that's what we need to deal with. We don't need to be dealing with all the conspiracy theories, because we don't actually have a lot of time for that, and it's not helpful. It doesn't change how we behave. It doesn't change how we actually approach this, because it's out there. So look, what I will say is it all depends on what measures your government is instituting and why they're instituting it. So currently, for example, in South Africa, we've had a couple of people, some tourists from other countries, as well as some South African citizens, who were tested and asked to self-isolate, told not to contact other people until they had the results of their test, and then they would be advised from there. One person was a salon owner in KwaZulu-Natal. They continued to do business, see clients, regardless. The tourists from another country then left the area where they were in and went to another province and actually got on a boat in an area where there's no current cases, got onto a boat with other people, and who knows how many people they've infected during that. And those people have actually been arrested and are being charged with attempted murder, because they were told there's a possibility they could have this, and by going out, they could harm other people. And so knowing this, they decided to do it anyway. it is a virus that can mutate. I mean, it did mutate. That's how we've ended up here. But it's actually mutating quite slowly. So different viruses, for example, the flu virus is an RNA virus, but the family of coronaviruses actually have a proofreading system. So mutation is not as fast as flu viruses. And scientists are looking at that. They're monitoring the mutation rate. They're looking at it and they're saying it's up to 2 mutations per month. And they're monitoring that and checking those mutations and seeing if it's a problem. So yes, it could mutate, but that's not necessarily bad news for us. It doesn't mean it's going to cause more disease or spread faster or be more severe. We don't know what it means yet, but scientists are constantly monitoring it. And an article that I read last night, which I can possibly share with you, kind of said that given the mutation rate and given what we're seeing so far over these few months, and again, we're in the early days, this hasn't even been around for a year, so we don't know what the seasonal cycle is. We don't know what the seasonal mutation rate is. We don't really necessarily know what it's going to do, but they're saying they're not that worried. They don't think that it's going to cause more disease or become more infectious at this stage. And this also provides hope for a vaccine. It means that we can develop a vaccine and there's hope for us being able to immunize a population. And you were saying earlier, could they force immunization? I would hope that the majority of people would want to stop the spread of this disease to other people. And I would hope that enough people would want that. Like when the smallpox vaccination came out, there were queues and queues and queues of people, and people wanted to get the vaccine because they didn't want this to spread to people. They didn't want their children to get it. They didn't want anyone to get it. And hopefully that will be the case when we have a vaccine, which I'm hoping we will have, and people won't need to be forced. And if enough people get the vaccine, then we will have herd immunity. And then it doesn't matter if every single person is immunized, as long as the majority of people are immunized. And if too many people are refusing, I don't know, maybe governments will have to step in. Different governments all have their own laws. Like in South Africa, we have an EPI, an expanded program for immunization, but our uptake is quite good. People who have access to the vaccine generally get it. But the World Health Organization has listed anti-vaccine rhetoric as one of the top 10 threats to our world health. And that will become even more important as we develop a vaccine for this. We know that flu comes around every year. Some of us have a little bit of immunity. A lot of us can get vaccinated. Many people, I get vaccinated for the flu every single year. So there's a lot of people who are vaccinated and they kind of result in a break in transmission. And we don't have that with this novel coronavirus. We don't have that at all. And we weren't prepared for it. We're prepared for the flu when it comes around seasonally. We know how many people are going to get infected. We know how many people are going to be severe. Doctors know when to send people for hospitalization. They have a manageable, let's call it, patient load. Whereas with this pandemic, although there were warnings from scientists for a while, governments didn't invest enough in healthcare. They didn't make sure enough hospital beds were available. And can we have been prepared for this? There's never been a pandemic before that we've recorded from a coronavirus. We didn't, although many people thought it could happen, we didn't see this coming. We weren't prepared for it. So it's not the same as flu. It's also not the same as flu because flu has a case fatality rate of 0.1%, whereas with this virus, it's 1 to 3.4%, depending on what age group and risk group you're in. For example, it's 0.2% in under 20-year-olds, but 15% in over 80-year-olds. So, as I've said before, I don't believe there is such a thing as just the flu, because the flu can kill healthy people, and so can this virus if they have the right set of circumstances. And then there's another woman who was in the Eastern Cape who said, yes, I've tested positive, but I have the right to freedom of movement. And she then went out and, I guess, infected other people. And we've got to look at how much are my rights important versus how much is the people around me, how much are their rights important. So we've got to look at this particular disease from a community perspective and say, does my right to movement override your right to safety, override your right to not get infected and killed by something, potentially if you have a comorbidity? And it's the same with vaccines. How much do your rights supersede everybody else's rights around you? And when we're looking at this pandemic in particular, your right to movement will override a lot of people's right to life, or right to movement themselves, or right to safety and security. So what our government has done when they've instituted, for example, a state of disaster, that then triggers a bunch of laws that then can be gazetted and override individuals' rights in certain circumstances. So say, for example, under normal circumstances, I can't force you to be tested for a disease. Under a state of disaster in South African law, the police can then approach the courts, who can give a court order that say, you have to be tested, you have to quarantine. If you don't, we will force you to. Then now with a state of emergency, they don't need to approach a court. A soldier or a policeman can tell you, you need to stay in your house. If you don't stay in your house, they can arrest you without a warrant. And that's the kind of responses that we have under a state of emergency. And that's helpful because it means that individuals who don't care about the common good can't actually then cause harm to everyone around them. But these measures, the government is also aware that they're infringing on rights, well, not infringing on rights, but that they're restrictive, and that there needs to be a period in which these are in place. So, for example, our laws say that the government can declare a state of emergency, but the longest that can go on for, they've said 21 days, they can extend it, but not past 3 months. After 3 months, they need to actually convene Parliament, which is a whole bunch of political parties who have been voted in and represent a lot of people in the country. And Parliament needs to actually say, okay, yes, we can continue with this, or no, this needs to stop now. So it's not like the government has the power to do this long term and then apply it to other situations. Definitely. I mean, there is a wealth of information out there. And I think, maybe in the future, if we can jot down some concerns that people have about vaccines, a lot of them are easily refuted. And there's a lot of misinformation out there. And I think that's also the important thing about a state of emergency. And even under a state of disaster, our laws then provide for, if someone is sharing misinformation, for example, on COVID, that could result in someone getting infected. Say, for example, if someone says, oh, if you put lemon juice on your hands, you can go out to the shops and you won't be infected. And then someone then goes out to the shops with lemon juice on their hands and is at risk of infection. The person who's sharing that information under the current laws can actually be arrested. And our current laws under the state of emergency and even under state of disaster provide for 6 months jail time for that person. So that's not what we're normally seeing. I mean, people prolifically share misinformation, and what in our family and circle of friends in the science community we call woo. People prolifically share things like this, and generally, yes, it's harmful. It's very harmful. It can result in loss of life. It can result in a child being infected with a disease that's completely preventable. But under normal circumstances, the government kind of doesn't interfere in that. But now with COVID-19, because of how dangerous it is for, let's say, 20% of the population that could have severe disease, even though only a much fewer will be in a situation where they'd need to go on ventilators, and even fewer would then go on to die, unfortunately. because it's so dangerous and it's infectious for such a long time, and it lives on surfaces and it can spread through a population that has no immunity. Because this situation is so severe, they've actually stepped in and made laws that say if you share misinformation, you can be jailed. So, for example, let's look at Samoa, who recently had a massive measles outbreak, which killed a lot of people. And it was all linked back to basically an anti-vaxxer saying that the measles vaccine is harmful, and she had her reasons for saying that. A lot of it, which is commonly debunked by anyone who can read a proper scientific article and isn't a conspiracy theorist who just believes things at face value and is kind of has the belief that I guess the majority of people want to harm them, because that's what you have to believe if you believe a lot of this stuff. If you believe that vaccines are harmful, you have to believe that just about every doctor, just about every scientist, just about every pharmaceutical company, the amount of people who would have to buy into that and be okay with it in order to say we recommend vaccination, you've got to believe that the majority of people out there want to harm you in some way. A lot of the things are very easily debunked, and yet people, once they have that opinion entrenched, they just don't believe your facts whatsoever. So say, for example, a lot of them say, oh, well, vaccines have mercury in them. They don't. Then they'll say, oh, but they have thimerosal, which is the same thing. It's not the same thing. So you're looking at a difference between, and just by the way, most vaccines don't have thimerosal in them anymore. It's a basically agent that stops multi-vial vaccines from being contaminated. That's what it's used for. Most of our vaccines that we give now are single-dose vaccines. So the difference is that thimerosal can be I guess, changed into a form of mercury by our bodies. But mercury is not mercury is not mercury. Just the same way alcohol is not alcohol is not alcohol. I can drink a glass of wine and it's not going to kill me. Some people say it's actually got some health benefits. Whereas if I take a glass of isopropyl alcohol from the lab and start drinking that, that's going to harm me. So that's what we need to realize with mercury as well. There's forms of, for example, formaldehyde that are produced by our body at very low doses. And we've also got to look at the dosing. Small amounts of something can be toxic, but small amounts of things cannot be toxic. And a lot of these things, they talk about mercury, for example, and there's more mercury of the harmful kind in a can of tuna than what you would get in a vaccine, which actually doesn't have the harmful kind. So yeah, that's, I mean, I suppose I could talk for hours on vaccines and the misinformation that people have out there. So yeah, I think let's leave that there, but I think Samoa should be a lesson to all anti-vaxxers about the actual harm that putting misinformation out there can do. There's no evidence for that, and I think in the beginning that was a big conspiracy theory, particularly as Wuhan had 5G technology in place. But then how would it then be spreading in countries like South Africa where we don't have that in place? So I think that's quite an easy one. And before we had any cases in other places of the world and they were first still discussing Wuhan, I know that a group that I'm part of had started to put out, I guess, some debunking. So yeah, I could make that information available to you as well. And it also covers, is this a man-made virus? How did Dettol know that we would have coronavirus? So they put it on the back of their label that Dettol is effective against coronavirus. And again, that's something that we have talked about, particularly in the early days. And I hope that the message has gotten out there that yes, this has been referred to as coronavirus, because in the beginning we didn't have a name for it. We knew it was a coronavirus, but coronavirus is a family of viruses. So I think a lot of people now know that SARS, MERS, and the common colds that kind of circulate every year. Those are also in the family of coronaviruses. But this is a novel coronavirus. So, they've forgotten, they didn't live through the 1918 flu pandemic. They don't know what it can do. So, if you ask people now, would you get a coronavirus, COVID-19, SARS-CoV-2, would you get that vaccine? A lot of people would say, yes, where's it? Bring it. I need it now. I need it for my whole family. I will stand in a queue to get that.
Yeah.
Ask them in 100 years' time when it's just coronavirus. I don't know.
Yeah.
And everything that I've said, I would love it if people said, well, what's the source on that? Can you provide the link that I can read so that I can validate it? If there's something that I've said that, people can go and Google and see, is that true? They should be doing that. I expect people to want to prove me wrong. That is science. That is what science is about.
Yeah.
Science is saying, you say this, I'm going to go about disproving that. And if I can't disprove it, then we'll say, okay, well, then it's probably true. And you'll kind of analyze and say, have I made the right amounts of effort to disprove it that it's probably true? So yes, you should be looking at things and saying, what was the date? And that particular voice note that's going around, and I know that it got sent to someone in England as well. Our health minister released a report yesterday of what the clinical situation is here in South Africa. And in that report, he says, well, there's 4 people in the ICU. And then later on, the report talks about how one of those people is 81 years old and they're on a ventilator. So yes, people who are over 65 are still going to be able to get into hospital, and they are still going to get treatment. They're going to make the decisions, some really tough decisions, but based on prognosis. They're not going to make it based on age or race. They're going to say, how sick are you? Do you have a chance to survive this? What can we do to help you?
Yeah.
I think that it's important to validate a source and be skeptical of it, and don't share it until you've validated it, because misinformation can be worse than no information at all. See, there's a lot of what you said in that previous video that really made sense to me. Like, look around you and see who needs help, and are you able to help them in some way? Because with all these lockdowns and only essential services, etc., there's going to be a lot of careers, a lot of businesses, a lot of economies that are just no longer applicable for a while. I was feeling so hopeless. I just felt like, wow, people are not locking down. People are not taking it seriously. Those who are not locking down and taking it seriously are going to continue to spread this. And that means that the lockdowns are going to be longer, and this is going to decimate our economies. And will we still be able to live? Those of us who are not essential services. I'm lucky. I think that, the world has seen how important people in my career are, but they're not necessarily right now seeing how important other people are. And everyone is important, and we need to value people. And while I was feeling hopeless, I just had this realization. There's a phrase that I quite often say to people when they're going through something so rough. I say to them, there's never been a storm that hasn't passed. And it just suddenly hit me. Look at us. For the last however many years, we've been okay. And there was a 1918 flu pandemic. And guess what? The majority of people are okay. Life kind of went on. There is hope. There's hope for the whole world. But we just need to, if we can, to expand that hope, to be hope for more people, to help more people. And for a lot of us, I have a very difficult discussion with myself, because I'm a person that in order for me to feel valuable, I need to be helping. And I had to leave my colleagues, who I know things are going to be very hectic for over the coming months. And I had to have a conversation with myself and say, yes, I could stay and help them with the molecular testing. But I'm an asthmatic. I could also contract it and then become a burden on the healthcare system. So how can I, as a person, help the situation? Stay home. Don't have contact with other people. Isolate myself. Don't hug my mom. Don't hug my dad. Wash my hands all the time. Make sure that if I'm infected, I'm not infecting them. And we have a 21-day lockdown in place at the moment. And I know that if I've locked down after 14 days and I don't have symptoms, I probably am not infectious. But up until then, I'm not sitting next to them. Maybe even after them, maybe it'll even be longer. Something in one of your previous videos which really spoke to me, you said check in on your strong friends. And during this time of isolation, I know when I was struggling a couple of days ago, I was talking to you and you gave me some tools. And, you know, a good way that I found to distract myself from feeling a certain way is to make sure a lot of other people are okay and have conversations with them. So I've been trying to like message a couple of friends that I know, know a lot about this, like other experts in the field or other people, and just make sure they're okay. I have a friend that I felt terrible leaving because I know that she feels that she has no one to call if she gets sick. And so I've asked her to just check in with me. So every day she sends me her temperature twice a day, and then we have a bit of a conversation and I check that she's mentally okay. And I think that's the thing. This is not only a physical virus, it's a virus that has resulted in a lot of potential isolation and can affect people's mental health. And I think that's something we also need to be very aware of. And we need to be reaching out to people, even people who we think are strong, and channel on every day. We can't have it on all day. If there's an announcement by the president, we'll turn it on. We'll keep up to date on social media, but we're going to limit the amount of news and devastation that's coming in, and try and focus on some positive things. And we've decided to put together a schedule. So, for example, we've got some things to look forward to on a Friday night. Saturday night is going to be a games night, and we're going to make sure we're playing games on a Saturday night. And then we're going to make sure that we're checking on everyone around us, do a lot more FaceTime, conference calls, etc., with family and friends, and just make sure we're checking in on everyone. And that's something that I've taken from what you've given to me, and I think that that's also a very important message. Also, it's important. I've got a lot of friends who are healthcare professionals or working on the front lines. For example, I've got some friends in our NICD, which is a National Institute for Communicable Diseases, which is, I suppose, the South African version of the American CDC. And friends working there who are seeing the worst of this every single day, healthcare professionals who are going to become physically and mentally drained, and they're going to be seeing the worst cases. And those are the people we need to really make sure we're going out of our way to support. If you have a friend who's a nurse or a doctor or an epidemiologist or a molecular scientist who's seeing cases every day, you need to check in on them and send them, make sure you're sending them some positive stories. For example, the news article that I was talking about, where they say that this virus isn't mutating very fast, relatively. I sent that to a friend of mine who I know is struggling with all the negativity at the moment, and just said to her, hey, here's some good news about this. And that's something that I think I know that you find very important, and it's very important for people to be doing that.